In this project video, I am discussing about the concept of phase and phase difference. It is a very important topic. How to calculate the phase angle of the waveform, or how to calculate the phase difference between the two waveforms. In that, first of all, I am discussing what is the phase angle of the waveform. The phase means it is called an angle phi of an alternating quantity which is traversed the distance from the origin. For example, the waveform is like that, then this is called angle phi. The distance of the waveform which is traversed from the reference origin on the x-axis distance, that is called the angle phi. Generally, if the waveform can be represented in terms of equation is E equal to Em sin omega t plus or minus phi. Here Em is the maximum value of the sine waveform and angle phi is called the angle, that is called phase angle of the corresponding sinusoidal waveform. Suppose if the angle is phase angle of the waveform is 0 degrees, then how to represent the corresponding waveform is when the phase angle is 0, then the waveform will be traveling through origin. That is, the waveform will be starting at origin. This is called origin point, that is 0 degrees. That's why the phase angle is 0. Then what is the equation becomes? E equal to Em sin omega t. Here phase angle phi is 0. And when the phase angle, the second case, when the phase angle is positive, that is the waveform is starting before the origin. That means at origin the value of the waveform, the instantaneous value of the waveform is positive at origin. Okay, at that point the phase angle is called positive phase angle. In that, the equation of the waveform you have to write down is E equal to Em sin omega t plus phi. So plus phi means the phase angle is positive and the waveform is starting before the origin. That means the instantaneous value of the waveform at origin is positive. Similarly, if the phase angle is negative, that means the waveform will be starting after the origin. That is here like this. That means the instantaneous value of the waveform at origin is negative. In that case, the phase angle is negative. Then you have to write down the equation is Em sin omega t minus phi. Okay. In this way, we have to represent the phase angles of the different waveforms. If the phase angle is 0, the waveform is starting at origin or passing through origin. If the phase angle is positive, the waveform will be starting before the origin. That means the instantaneous value of the waveform is positive at origin. And if the waveform is starting after the origin, that is positive peak, that is positive off cycle, is starting after the origin. That means the instantaneous value of the waveform at origin is negative, then the phase angle is negative. Okay, like that we have three types of waveform condition. Phase angle is 0, positive phase angle and negative phase angle. Then by taking some example, we must understand how to write the waveform for the phase angle. Suppose the waveform E is given 10 sin omega t plus 40. That is how to draw the sinusoidal waveform for the given equation. That is, the reference is omega t, waveform is voltage Z, then what is the maximum value of sin is 10. Here the phase angle is plus 40. What is the meaning here plus 40 here? The waveform will be starting before the origin. This phase angle distance from origin is 40 degrees. Then the maximum value is here 10. Like that you can draw the waveform for the given equations. Okay, this is called the phase angle of the periodic waveform or any waveform shape. Then the next concept is very important and very useful in problems also, that is the concept of phase difference. If you have to find out the phase difference, you must know the phase angle of the waveform. That is the concept of phase you must know. Then it is easy to calculate the phase difference. Okay, what is the definition of phase difference? That means the difference between the two phases of the two alternating quantities. That means the difference between the phase angles of two alternating quantities. That is called the phase difference. Suppose we consider two waveforms, that is voltage waveform E equal to Em sin omega t, and current equation, for example, I equal to Im sin omega t plus 5 or minus 5, anything you can consider. Here we know what is the phase angle of voltage equation 0, and what is the phase angle of current equation 5. Then what is the difference between the phase angles of voltage and current waveform? That is 0 and 5. That is 5 minus 0, 5. That means the phase difference in this equation for both equations, by comparing voltage and current equation, the phase angles difference between two waveforms is 5 degrees, okay, for this equation. Then how to identify the phase difference with respect to waveforms also, you must know that. That means, that is, by taking reference above equations, you can draw the both equations on single reference axis. Okay, here the voltage equation is E equal to Em sin omega t. The phase angle is 0. This is the voltage equation. Similarly, what is current equation? The current is phase angle phi. That means the current waveform will be starting before the origin. Okay. Then this distance is called phase difference between the two difference between phase angles of two waveforms. Here for equation of E, the waveform is phase angle is 0, and for current equation the phase angle is phi. Then the distance on the x-axis between two waveforms is phase difference. The difference, or this is also called phase difference at the ending points of the two waveforms. Okay, in this way, we have to calculate the phase difference by comparing the phase angles of any two waveforms or any two equations. Okay, this is the phase difference concept. This phase difference concept you can analyze by considering very simple example. Suppose E equal to maximum value is 10 sin omega t and I equal to maximum value is 5 sin omega t minus 60 degrees. Then what is the phase difference here? That is 60. Okay, phase angle of voltage waveform is 0 and phase angle of current waveform is 60. Then phase difference is 60 degrees simply. Then you can analyze that phase difference with respect to waveforms also. Then you can draw two waveforms on single reference axis, that is omega t, and for equation E, voltage equation, phase angle is 0. That's why passing through origin, that is, this is called waveform voltage. Similarly, what is the waveform current here? Minus 60 degrees. That means the current is starting from after origin. Okay, this is called 60 degrees, the distance between voltage and current, and this is also called 60 degrees difference. Then by comparing these two waveforms, what is the phase difference here? The phase difference between the current and voltage waveforms is 60 degrees. Therefore, phase difference in this example by comparing two waveforms is 60 degrees. In similar way, we can also find out another example by taking here the voltage equation is 10 sin omega t plus 30 degrees, and current equation 5 sin omega t minus 60 degrees. Then in this case, what is the phase difference? Then clearly understand this model is very most important to find out the phase difference between two waveforms. How to find out? X-axis is omega t. Then first write down the voltage equation. That is maximum value is 10. What is the phase angle of voltage in this example is 30 degrees plus 30. Plus 30 means the waveform will be starting before the origin. The instantaneous value is also positive at origin. That means this distance is 30 degrees. That is the voltage waveform. Similarly, what is the current waveform? Then what is the maximum value of current is 5. Then what is the phase angle of current is minus 60. Minus 60 degree means the current waveform will be starting after the origin. That means here. This is current equation and maximum value is 5 and voltage equation maximum value is 10. Then the distance from the origin is 60 degrees. Then what is the phase difference between these two waveforms here? What is the distance between the two waveforms? That means from voltage to current waveforms, what is the phase difference here? That is 60 and 30. Totally, what is the total angle here? 90 degrees. Okay. This 90 degrees is called phase difference between two waveforms. Like that, we can calculate the phase difference between any two waveforms. Okay, here the voltage equation should be starting at phase angle 30 from reference 0, and also the current equation is minus 60, that means it will be starting after the origin. Then from the origin, before the origin we have 30, and after the origin we have 60. Then the distance between the two waveforms from voltage to current waveform, total distance is 30 plus 60, the angle is 90. That 90 degrees is called as the phase difference. Then similarly, we are taking another example, that is the voltage equation E equal to 10 sine omega t plus 90 degrees, and current equation 5 sine omega t plus 30 degrees. Then what is the phase difference? How to understand the phase difference here? Okay. Then here the two waveforms having, both are having positive phase angle. That's why both are starting from before the origin. That's why the voltage equation is okay, this is the 90 degrees for the voltage. Similarly, for the current, it will be starting 30 degrees. Current will be starting 30 degrees. Then okay, then here the distance is 30. Then what is the phase difference between two waveforms here? That is the distance between the voltage and current waveform. That is 90 and 30. 90 minus 30, 60 degrees. The remaining is 60 degrees. Then this 60 degrees is called as the phase difference between these two waveforms. Okay, in this way, like that, we can calculate the phase angle and phase difference between any two waveforms. Then, according to the phase angle or phase difference, then we have to find out what is the lagging condition and what is the leading condition of the waveforms here. Okay, the first condition is in phase condition. In phase means this is first condition. This is suppose voltage equation, and this is suppose current equation. Okay. Then what is the in phase condition means? That is called if both waveforms are having the phase and phase difference are zeros, nothing but on reference x-axis both waveforms are intersecting at the same points, then the phase difference is 0. Okay, that is called the in phase condition. That is in phase the phase difference is 0 degrees. What is the in phase condition? How to understand both are in phase? Both waveforms are intersecting at the same points on the reference x-axis. That is called the in phase. And similarly, the second condition is lagging condition. Lagging means behind. That is the after. That means here, suppose this is voltage waveform, phase angle is 0, and second one is current waveform, then what is the phase difference here? Phi. The distance between the two waveforms is phi. This is called I, that is current, lags voltage V by an angle phi. That is, I is lagging the voltage V, voltage E by an angle phi. Or the same terminology you can also call the voltage E leads the current by an angle phi. Okay, this is called leading conditions also. Like that, you can understand what is the leading and what is the lagging, how much angle will be lagging, how much angle will be leading. So that is called the lagging conditions. And the third one is leading condition. How to understand the waveforms are leading. Leading means the waveform will be starting before the origin. That is, same the reference waveform, voltage waveform is starting 0, the phase angle is 0 of the voltage. Then similarly, the current equation will be starting before the origin. This is current equation. Then the phase angle of current is phi. Then what is the total difference between two waveforms here? The phase difference is phi, okay, between the current and voltage. Okay, this terminology is called leading. That is, I leads the voltage E by an angle phi, or the voltage E lags the current I by angle phi. Okay, in this way you can understand leading conditions also. Okay, lagging means the waveform will be starting after the reference waveform. Leading means the waveform will be starting before the reference waveform, that is before the origin or before the reference waveform. Here in this consider we are considering reference waveform is voltage, so that is called leading condition. Okay, the same technology also you can understand by taking the simple example, that is what is the leading and what is the lying condition here. That is, consider example here. The voltage waveform, that is maximum value is 10. Similarly, the current waveform, maximum value is 5. The phase difference between two waveforms suppose is 60 degrees, for example. Not 60, for example 120. Okay, that means the maximum point we have 90 degrees, that's why it will be starting after the 90, that's why I am taking 120 degrees. Then here, what is the meaning here? That means the current I, this is voltage E and this is current I waveform. The current I lags the voltage E by an angle 120 degrees, or the same terminology we can also use in terms of leading also. That is, the voltage E leads the current I by an angle 120 degrees. Okay, like that we can find out phase difference between the difference between phase angles of any two waveforms, or we can also understand what is the leading condition or what is the lagging condition between any two waveforms. Okay, in this way we can find out the phase, what is the phase angle of the waveform, what is the phase difference between the two waveforms, so what is the condition between the two waveforms, that is the leading condition or lagging condition, or both are in phase condition. Okay, in phase means the phase difference is 0, both waveforms are intersecting at the same points on reference x-axis. Please subscribe our channel and share to your friends.